Okay, now that we have an image on the screen, we are going to move it around. But first, a couple of things that will make your life a little bit easier if you do these in the future. One thing is we want to create a rectangle that is the size of our screen. Now, the default is 800 by 480, but it doesn't have to be that. So we are going to create another rectangle variable. We're just going to call it screen rectangle. And we're going to set it equal to the default at the beginning. It'll be the first thing we do in every program. So screen rectangle equals, and instead of doing 4 assignment statements to set the x and the y and the width and the height, we can just say new rectangle and then give it the x and the y be 0, 0, and the width and the height would be 800 and, 480. Okay. And then when we're checking to see if our image is on the screen or not, we will compare it to this. And if we resize our screen somewhere along the way, we'll change it right here, change these two numbers, and we won't have to change another single line in our program. We'll make everything relative to our screen rectangle. Okay. And another thing I want to do is down here on the saucer size, I'm going to cut these two out and put them above the x and the y. Normally you think of doing the x and the y first, but I'm going to set the width and the height first, and then down here I can say, instead of 400, I don't want to use 400 because if I change the size of my screen rectangle, I want it to be the middle of whatever that is. So I'm going to do screen rectangle dot width divided by 2, so that'll get me to the 400. And then I want to subtract the saucer rectangle dot width divided by 2, and that'll get me in the center. Okay. Then down here, instead of 240 and 20, again, I want to do screen rectangle dot height divided by 2 minus the saucer rectangle dot height divided by 2. Okay. This is going to look exactly the same as the last program did in the previous video, but it's going to be much easier to modify because we've done this. So if I go ahead and run this, we'll see the saucer right in the middle of the screen, and then the next thing we'll do is we'll take a look at how you can start moving it around. Okay, there it is, exactly the same as before. But the program that did it is better written than the one that we had up here in our previous video. Okay, now that we've got it on the screen, let's start moving it around. We can have it move around on its own, or we can have it move around under the control of the game player using the gamepad or the keyboard. What we're going to do first, though, is just have it move around on its own, and we're going to figure out how to keep it on the screen. So we're always going to get rid of this exit statement here because we're always going to put in our own. Okay, so what I want to do every time is I want to move my saucer across the screen, and I'm going to move it to the right first. So all I have to do is change the x coordinate of the rectangle. So saucer rectangle.x plus plus. So that will move it 1 pixel to the right on every tick of the clock. After 1 second, it'll move 60 pixels. We have about 400 pixels to move before it disappears off the screen. So if you divide 60 into 400, it's going to take about 7 seconds to move off of the screen. So let's go ahead and run it. That's all that we have to do to move it, is just change the x or the y coordinate. Okay. And it should take about 7 seconds to get across. And then it disappears. Okay, we're still adding on to it, but the coordinates are no longer on the display area, so it just disappears. Okay, let's move it in 2 directions at the same time. Let's do saucer rectangle dot y plus plus, and the y direction is down. 0 is at the top here. It's not like a regular Cartesian coordinate system where you usually work in the upper right hand corner. We are using the lower right hand corner. So this should move at a 45-degree angle down and to the right until it disappears, and it's going to hit the bottom before it hits the right side, so it's going to disappear off the bottom. Okay, so it's easy to make things move around on the screen. Just change the x and y coordinate of the rectangle that they're being drawn in. So what I want to do is I want to keep this on the screen, and the way I want to keep it on the screen is when the bottom of the saucer hits the bottom of the screen, I want to reverse the y direction, so it's just going to kind of seem like it bounces off. So instead of adding 1 to the y coordinate every time, I'm going to be subtracting 1 from the y coordinate. Okay? So what I need to do is I need to be able to check some things. So every rectangle, so here is my screen, and every rectangle has an x coordinate, which is the distance from the left edge of the screen, a y coordinate, which is the distance from the top of the screen. And they also have alternate names. You can also call them, x can be called left and y can be called top. There is one small difference between these two. Left cannot be used on the left side of an assignment statement. Top cannot be used. So if I want to change the x or the y, I have to use the x or the y on the left-hand side of an assignment statement. Okay, but top and left come in handy sometimes. We can look at them and see what they are. Then we also have the width, which is the distance from here over to here, and we have the height, which is a distance from the top all the way down to the bottom. So in this case, I've got 400 pixels wide and 200 pixels tall. Now, what really comes in handy when you're trying to keep things on the screen is there is a value for this distance from here all the way over to here is 200 from the left edge of the screen to the left edge of my rectangle, and then I've got another 400. So that is coordinate 600, and we can refer to that by using right. And same thing, there's one for the bottom as well. The bottom is the top, which is 150, plus the height, which is 200, so I get 350. So I can reference the right edge and find out what coordinate the right edge is by using right. I don't have to say left plus width or x plus width. I can just refer to right. And I can refer to bottom instead of using, y plus height or top plus height. So it makes your coding a little bit easier, and the names are, descriptive too, so that makes it pretty easy as well. So let's flip back over to our game here, and what I want to do is, I know I'm going to hit the bottom first, so I need to have an if statement in here. If the saucer rectangle dot bottom is greater than or equal to, I don't want to just check for equal here. If it's greater than or equal to the screen rectangle dot bottom, then what I want to do is turn it around. Okay, well, to turn it around, you start subtracting from the y, and I'm going to have to make some changes in this. Instead of doing the plus plus, what I'm going to do is I'm going to have up here I'm going to have two integer variables, x speed, int, x speed and y speed. Okay, and those are things that should be initialized and initialized. So I'm going to set x speed equal to 1, and I'm going to set y speed equal to 1. And now down here, instead of doing a plus plus, I'm going to do plus equals x speed. Okay, I'm going to do the same thing for y. And this is just a shorter way of writing saucer rectangle.x equals saucer rectangle, dot x plus x speed. Okay, so if you want a variable and you want to add something onto it, you don't have to put it on the right hand side of the assignment statement again. There's a shortcut, and it's plus equals. So this statement right here and this one over here are exactly equivalent, but the first one's easier to write, so that's the way we're going to do it. So I'm going to add the x and the y speed on every time. That's not going to change anything. But if I get to the bottom, then I want to turn my y speed around. So y speed is going to be equal to minus y speed. If y speed is a +1, this will turn into a -1. If it's a -1, it'll turn it back into a +1. Okay? So let's try that and see if we bounce off the bottom. Okay, we reverse the y direction. Now we need to do the same thing for the x. If we go off the right edge, so if the right edge of the saucer is greater than or equal to the right edge of the screen, then I want to turn around my x speed. Okay, so that should get us bouncing off both the bottom and the right. Now, of course, when I get to the top, it's going to go off the top. Okay, so I need to check for my other two edges as well. So I need two more if statements here. If the top of the saucer rectangle is less than or equal to, because that's 0 up there, we don't want to go into the negatives, the screen rectangle dot top, then I want to reverse the y again. So y speed equals minus y speed. And then the same thing for the left. If the saucer rectangle dot left is less than or equal to the screen rectangle dot left, then I want to reverse my x speed. Okay, and now we should have a flying saucer that bounces forever around the screen, bouncing off all four edges of the screen. And it should bounce off this one as well. And that's going to go on forever. So that's how you keep something on the screen. Just compare its top or bottom or left or right, with the top or the bottom or the left or right of the screen rectangle that you're drawing it on.